Okay, let's use molecular orbital theory and concepts of delocalized bonding to relate back to the resonance structures that we've seen in previous sections. Okay. The case I'd like to present here is that of the propenyl cation C3H5+, which if you add up is a 16 electron in the valence shell molecule. There are a couple of ways you can draw a structure of a localized electron structure of C3H5+. First is shown here. You've got a double bond between one set of carbons and a 6-electron positively charged carbon left at one end. Of course, there's no reason that the electrons have to be on the left side of the molecule. There's a second way you could draw this structure with the double bond on the right side and the positive charge on the left. And these are really resonance structures of the propenyl cation. The molecule exists as a hybrid of those two structures. That's the way we think about resonance. And so you could draw a structure in which that pair of electrons in the double bonds is delocalized across the 3-carbon framework here. It's necessarily true that that electron density must be essentially coplanar above and below the 3-carbon skeleton. And what we've got here is a pair of electrons that are shared among the 3 p orbitals in the sp2 hybridized carbon atoms. So if we drew this picture, what you can think of is now kind of looking in the plane of the carbon-carbon-carbon skeleton. 3 p orbitals that are all oriented up and down here. So in that sense, they are coplanar or periplanar. And the overlap between all 3 of those p orbitals gives rise to a series of molecular orbitals. In this case, there are 3 atomic orbitals going in, so there must be 3 molecular orbitals coming out. And it's the net sum of those 3 orbitals that's present in the molecular orbitals. And in this case, there's a low energy molecular orbital that has constructive interference, good mixing between the 3 p orbitals. You can think of that as a delocalized molecular orbital that has a pair of electrons in it. And that corresponds to the averaging of the 2 resonance structures from the Lewis dot picture of the electronic structure of this molecule.